So in this question we have to calculate the twisting couple that is needed to twist this hollow cylinder by an angle theta. So here let's first understand the problem. So this is our hollow cylinder. The inner surface has the radius r1 and the outer one r2. And now we consider one another hollow cylinder which is in between r1 and r2, which has the radius of x which is less than r2 and it is greater than r1, whose thickness is dx. The thickness is dx of this cylinder, and as you can see the cross sectional area, or let's say if we look at from one end, it will look like this. The hollow cylinder is between the two bigger cylinder, one smaller and one bigger cylinder. Now we try to rotate this. So if you look from one end, it will look like something like as we can see here, this part. If we are rotating it through an angle theta, then the lower end, or let's say one end, will look like this. On the other hand, if we look from the outer surface area, then this will look like as shown in the figure. Now this angle phi, this is the angle of shear by which its shape has changed, and this theta is the angle of rotation, of twist that we are producing in it. This phi, the shear angle is taken on the outer surface, because the shear, if we look at a cylinder, then the shear is 0 at the axis, at the point of axis. So for example, this is our cross sectional view, and here if we are measuring shear at this point at the center, then it will be 0, and it increases linearly and becomes maximum at the outer surface. So this point phi, this is being measured at the outer surface and it is maximum. Now let us delve into this mathematics. So there is the definition that the twisting couple, it is a pair of equal and opposite forces. So what we are doing here, let's say we are holding the upper end and we are trying to rotate the lower end in a plane. Okay, so let's say this is the view of from that lower end, then we are rotating it in this direction using a tangential force, and this force will act like a torque about this origin, right? Because we know torque is the first moment of the force about some origin or about some axis, so that torque will induce the rotation. Now here, so first thing is that if you look very closely, then you can see that this arc length that we have highlighted here, and this arc length that is at the outer surface of the cylinder, which is of radius x. So these arc lengths are equal in both the cases. So this can be written like, we know that arc divided by radius gives the angle between the two. So if for the outer surface, because there is the length of the cylinder, this length is L. So if we write this for the outer surface, then phi means the shear will be this arc upon length, where length is L. And for the lower end, this angle of twist, that is theta, so angle of twist theta is equals to the same arc divided by the radius of the hollow cylinder that we have assumed, which is x. Now we can equate both of them. Since arc is common in both of them, so we can write L times phi is equals to x times theta. Now we know that phi is the shear, so phi is equals to x times theta divided by L. So this is the shear. Now we know in this case, since we are talking about shear, so we talk about the shear modulus. So shear modulus eta is shear stress divided by strain, the shear strain. In our case, the shear strain, that is phi, that is the shear. Basically shear strain is shear, so this is equals to phi. So the shear stress can be eta times phi, which is nothing but eta x theta divided by L. So this is our shear stress. Now we know that the shear stress, or the stress, basically it is nothing but force divided by the area on which it is being applied. Okay, so in this case, since the area on which we are applying, that is the area of its cross section at which we are applying the force or the stress that is being applied, so that area is nothing but 2 pi x, because 2 pi x is the perimeter of this hollow cylinder's cross section, and dx, if we will multiply it with dx, that is the width of this hollow cylinder, then it will give us the cross sectional area at which we are applying the force, the tangential force. Now this area, if this is divided by the force that we are applying, is nothing but, so force that we are applying, and that is tangential force, it is eta times x theta divided by L. So this is what we have. Now please look at it, that this force is being applied tangentially, so it is always perpendicular to the origin about which it is being applied. So if we need to calculate the torque that is being produced by this force, it will simply be the product of the distance from the origin with this force. So we can write it, this torque equals, that we know it is always, it's a vector quantity, and it can be written as, let's say here it is x times the force that we are applying, but since these both are perpendicular to each other, the x and the f, so we can write it x times f, and it is perpendicular. Okay, so the torque is perpendicular, because this is, if we can determine the direction of the torque, that is r cross f. Okay, so let's say this is x and this is f, so it will be into the plane. Okay, into the plane, and that is how it is reducing the torque, the twist. So if we deal only with the magnitude, then we can write it like this, and this torque which we have to find out, it is nothing but, if we multiply these all things, what we do from the above equation, we write the expression for force like eta theta divided by L 2 pi x squared dx. Now we multiply, or we substitute the value of the force in the expression for this torque, then we can write that torque equals to eta theta divided by L 2 pi x cubed dx. But this torque is acting on a very small element, that the hollow cylinder. of radius x and width dx. So we can write in front of this tau d tau. And to calculate the torque on the complete hollow cylinder whose inner radius is r1 and the outer radius is r2, we need to integrate it over the limits from r1 to r2, where x is going from r1 to r2. So this tau will be these, because these all are constants like eta, theta, l. So and x will go from r1 to r2, and if we solve them, we get so this is the required expression for the torque that will be produced in the hollow cylinder when we apply the tangential force of magnitude F.